I'm a real secondary school science teacher, and Liam Cooper wants to know about elementary particles. And before we start this video, let me preface it by saying I am not a physicist, and this is a very complex topic, but I'm gonna do my best! Elementary particles, otherwise known as fundamental particles, because they are fundamental to reality as we understand it, are not made up of other particles the way atoms are, but instead are the building blocks for literally everything else. There are fermions, which make up matter and antimatter, and bosons, which make up forces. What does that all mean? We'll get to it. One thing I can tell you for sure is they've got great names. Like, we've got the ups, we've got the downs, we've got the tops, we've got the bottoms. Physics really said gay rights. Within the fermions, you have the quarks and the leptons. Both of these have 3 generations of paired particles. Generation 1 of the leptons is the electron. Now, you may remember the electron from high school chemistry class. It is the teeny tiny negatively charged particle that rapidly rotates around the outside of a nucleus of an atom and is what causes some chemical reactions to take place. As I mentioned earlier, leptons come in pairs, and the electron's pair is the electron neutrino. The electron is responsible for electric currents, and the electron neutrino has no charge and is produced by the sun. Because electron neutrinos have no charge, they interact very weakly with everything in the universe. In fact, millions of them are passing through every square centimeter of your body every second, day and night, all the time. In spite of this lack of interaction, these particles are vital to survival as we know it because they help disperse elements like carbon and oxygen, which are fundamental to human existence, throughout the universe from supernova explosions so that we have access to them here on Earth. Generations 2 and 3 are the muons and the tau, I don't know how it's pronounced, and their neutrino pairs. As it stands, these particles are totally needless and don't really do anything. They were vital in the first 10 seconds after the Big Bang because they established the structure of the universe as we know it now. But for now, you know what? They've earned their rest. They're just kind of here, hanging out, being needlessly complicated. On to the quarks, or the force particles. We have up with down, strange with charm, and top with bottom, previously known as truth and beauty. So, the next time you're wondering if you're a top or a bottom, what you should really be asking yourself is, are you a truth or are you a beauty? Quarks stick together and form things like protons and neutrons, and this is why it's possible for atoms to exist. Much like the leptons, the lightest pair, the up and down, play a vital role in the formation of atoms, and the other two were really important in the beginning of the universe, but now they just kind of hang out. And to top things off, all the fermions have a nemesis in the form of antimatter, with the exception of the electron, whose nemesis, whose opposite, is a positron. So it has a positive charge, which makes sense because the electron is negatively charged and they're opposites. The antimatter versions are called anti-up, anti-charm, anti-down, etc. Have we ever found or seen or interacted with antimatter? Yes, we use it in hospital PET scans all the time. This is also why it is impossible for matter to be either created or destroyed, because in order to make matter, you would have to also make antimatter, and the only place you get antimatter is in cosmic collisions in space. So good luck with that. Quarks are colorful. They can be red, blue, or green, and these colors appear to have some impact on how they interact and form other things. When they form protons and neutrons, they become colorless, much like how the spectrum of visible light works if you put it through a prism. Speaking of light, let's discuss other forces. We've got the photons, gluons, and bosons, W and Z. Before we can move on, we need to talk about the 4 vital forces of the universe: fire, water, earth, and air. Just kidding. The real 4 forces are gravitational, electromagnetic, strong, and weak. Now this leads us into a problem, which I'm going to explain. Photons are responsible for the electromagnetic spectrum and are also responsible for light. Light is both a particle and a wave. The strong forces are represented by gluons, which are responsible for gluing particles together so that you can get things like neutrons and protons. Then we have the weak forces, which are bosons, W positive, W negative, and Z zero. These are responsible for radioactive decay, which we can use to date the age of things, along with a few other really interesting scientific applications, and they make the sun shine. Oh. This covers what we know so far, and you might have noticed I left out the force of gravity. So, what causes gravity? Probably gravitons. Have we ever found them? Nope. But it stands to reason that they exist, because I'm not about to float away. The final boson you may have actually heard of because it's fairly famous, the Higgs boson particle, which was first theorized in the 1960s, but we didn't actually discover it until the Massive Hadron Collider at CERN in 2012. Best I told you so ever. The Higgs boson particle is said to be the origin of mass because it gives mass to the quarks. This is everything we understand so far. Is there more? Yes, so much. Complicated things like string theory, which I am not going to talk about unless 100 people demand it in the comments below this video. Because again, I am not a physicist. Yet. And this is really exciting. It's great when we don't know stuff because it means that there's more out there to discover. So remember, science kiddos, there is no room for shame when growing your brain. If there's a science topic you'd like to know more about, then comment below or reach out to us on social media. In the description of this video is some additional reading material because it's very important that you always do your own research and come to evidence-backed conclusions.